Good morning, everyone. Thank you all for being here. My name is Lauren Bernstein, and I'll be presenting on HR 765, Water Infrastructure Resiliency and Sustainability Act of 2013. Before I begin, I'd like to thank my entire team for their help with this output and for a great semester together. And I'd also like to thank our professor, Professor Howard Apsan, for his guidance and support throughout the semester. During today's presentation, I'd like to briefly discuss a brief review of the issue at hand and the response presented by HR 765. HR 765 is a grant program, so we're going to be looking at what kinds of programs would be funded by the grant, and we're also going to be talking about controversies that are surrounding the bill and the programs that it's going to fund. We're also going to look at measuring the bill's success. And finally, I'm going to wrap up with a summary and final thoughts. The issue at hand is changing hydrological conditions. These changes will exacerbate water quality and quantity problems around the country. Therefore, there is a need to increase resiliency and sustainability of our water systems. The water system is made up of a vast number of interconnected parts, all of which experience their own infrastructure problems and contribute to environmental issues. Some of the water infrastructure in the United States was built at the time of the Civil War. Most of these water systems are not suited to handle the repercussions of changing hydrological conditions that are taking place all over the country, like these maps demonstrate. The response to changing hydrological conditions can come in the form of our bill, HR 765. The bill seeks to establish a grant program that will provide $50 million to be distributed every fiscal year between 2014 and 2018 to owners and operators of water systems that are challenged by changing hydrological conditions. There will be special considerations for proposals that aim to use innovative approaches to increasing resiliency or adaptability of water systems. By hydrological conditions, the bill is referring to quality, quantity, and reliability of water resources. The primary goals of the bill will address problems with all aspects of the water system. When it comes to changing hydrological conditions, there is no one project that solves every problem across the country. Therefore, we need a national plan that supports a broad range of solutions. Some of the solutions that meet the goals of the bill can be found on this slide. These are the kinds of projects that could be funded by our bill. One goal of the bill is the enhancement of natural systems. One example of a project that meets this goal is wetland remediation. A restored wetland can reduce future stress on ecosystems by reinforcing natural ecosystem services. Another goal of the bill is the development of decentralized, low-impact infrastructure solutions. Porous Concrete is a project that falls into this category. By replacing a non-porous surface with a permeable one, it reduces the stress of traditionally large water infrastructure systems like wastewater treatment plants and stormwater mains. Another goal is the reduction of water demand. Examples of this are technological enhancement and regulatory solutions, such as smart water meters and adaptive water pricing. Projects like these will reduce the stress on water supply by regulating demand and making people more aware of their consumption habits. These projects show us how the bill seeks to provide infrastructure solutions at every stage of the human water use. Controversies surrounding this bill sort of range from a broad scale to a more narrow focus. A broader question about climate change can be sort of looked at by when we look at our bill 765's history. Some version of the bill has been introduced 3 times. This time around, it has 24 Democrats supporting it and 0 Republicans. Of the 24 Democrats, 7 of them are from California. Why is this bill stalled when changing hydrological conditions are a concern all around the country? The reasons it hasn't gotten much traction may be political. There are differences of political opinion about how federal funds should be spent. A more narrow controversy could be centered around an individual project. For example, the Santa Barbara desalination plant. A desalination plant such as this one, I'd like to point out that although it's a large project and the whole thing could not be funded by our bill, they could certainly apply for a smaller portion or smaller project that's incorporated in the plant could meet the requirements of our bill. But a controversy surrounding the bill is that a controversy surrounding a desalination plant is that it creates a natural resource in the form of drinkable water for humans, but at the same time, it harms an ecosystem. There are also issues of resiliency that will surround every project. Will the project have a strong enough impact to justify the money that is being invested into it? Will the small change from a small project make a worthwhile impact? Another controversy is about measuring the effects of the bill. The funding from the bill is slated to last for 4 years. Can we measure the resiliency and sustainability in that amount of time? The answer is we can try. Scientific indicators applied to measuring the program's success are based on the goals of the bill, which are improving water quality and quantity and increasing resiliency and sustainability of water systems to face negative impacts from changing hydrological conditions. There are already measurements in place that we can sort of use as an example. The first measure would be water quality. By measuring this, we can measure water flow. Measuring water quality, we can set up sampling stations. Improved resiliency is a little bit difficult to measure because it can really only be measured after the fact, after either a natural disaster or a particularly hard rainstorm. Ecosystem restoration is also difficult to measure, but there are already models in place around the country that we can look to as an example. For example, the Chesapeake Bay uses a program called BayStat that measures aquatic life and water nutrients. The results of these kinds of measurements can help assess the health of a restored ecosystem. It's important to point out that the bill is quite broad, but uniform standards will dictate the measurements for every type of project. Specific measurements will vary depending on individual cases. Overall, the bill supports a multitude of solutions to an urgent and complex issue, improving infrastructure in the face of changing hydrological conditions. The bill supports small projects that can be replicated all over the country and that can have significant impacts, in addition to supporting bigger, more expensive projects. Next semester, we'll better understand how projects can be financially and structurally implemented. In conclusion, I'd like to thank you for your attention and participation all summer. Are there any questions?
Thanks, Lauren. You had mentioned, I think in one of the slides, a program surrounding a regulatory solution. I think it was adaptive water pricing. I was just curious if how the bill determines how money can be used. So in something like that, it seems to be no physical infrastructure. Would the $50 million go towards, say, like a market research on what water pricing should be, or how would it be used in a context like that?
Oh, that's interesting. I'm not sure if it would go towards market research, but I know that it would at least go towards implementation. If a city or a municipality comes forward with a project and they know they want to do this, then this grant could definitely go towards that.
Hi, thank you for your great presentation. You mentioned that one of the possible projects would be to replace impermeable surfaces with porous concrete. I was wondering if the concrete production could have possible negative ramifications through increasing carbon dioxide.
That's a good question. I think the point of the porous concrete example is if concrete is going to be laid there anyway, maybe the porous concrete's a better option. But again, there are qualifications in place. I think a municipality would have to come forward with a project, an idea, and maybe show the research of why it needs funding, and maybe that's something that could be covered in that kind of a proposal. Okay, thank you.
Well, first, I want to congratulate all the groups and all the briefers on a group of spectacular briefings. So let's give them a collective round of applause. Part of my task as we conclude is to talk a little bit about what this was about and why we are doing this. We obviously, as a faculty, think that this is a very important part of the curriculum here in the program because it's the part of the program where we bring together all the discrete areas of knowledge that you're learning one course at a time. And in the real world, you don't have a separate period of time to look at chemistry, a separate time to look at politics, a separate time to look at economics. You actually have to bring all of that knowledge together in a problem-solving exercise. And in fact, you will be addressing problems and trying to make things less bad throughout your entire career. At the very beginning of my career, I was looking at one set of issues, and as time went on, I was exposed to and asked to look at other issues. And those issues will change depending on changing social and technological and economic and cultural factors, and so the definition of problems changes. What doesn't change is the process of learning and addressing problem solving, which is what the workshop tries to do. So one question I always ask students at this point in the semester to ask yourselves is, think about the problem you've been spending the summer working on. Think about how much more you know about that issue today than you knew about it when you arrived here the day after Memorial Day or the day after that when you got assigned to these groups. So you know a lot more, and part of the reason for that is that what we do in the workshop mirrors the way professionals learn. You focus your attention on solving a problem, and that disciplines your approach and what you're learning. So for example, today some people were asking questions about the fall semester workshop, and you know, it naturally stems from what you've already been addressing over this semester. Again, we're focusing on the science now. You know, it's hard to separate the science from the policy and the management because problem solvers really have to integrate that. In the fall, we'll be working on those things. But we're using the problems themselves to help you learn a number of things. So what did we learn this semester? Well, first, what policy analysts call cutting a problem down to size. There's lots of pieces of the problem you really can't address. The question that was just asked about concrete. Yeah, we definitely produce carbon dioxide and other kinds of things when we're making concrete. Is it worth the cost of demolishing the old concrete to put the permeable surfaces? That's an important question. That's the question you ask. Neither is perfect. You know, human beings on the planet are going to have an impact one way or the other. So the question is, which impact is worth it, and what is the impact? But that's learning through a problem-solving approach, where you're learning how to think about these problems. You also learn how to work in groups. Everything this summer seemed to be in groups. You learned how to do things under tight deadlines. You learned how to communicate a lot of complex material in 10 minutes. Some of you went to 11. We'll work on that for next semester. In the real world, you often don't even get the 10 minutes. You get the 3 minutes. You get the 2 minutes on the elevator. You're walking with somebody to their car, to the subway, trying to get the 90 seconds you have to get across the key bit of information. Because the world is getting complicated, and there's a real premium on being able to simplify that complexity to actionable items, which is a lot of what you're doing throughout the semester. And so you've accomplished an enormous amount. You know a lot more about these problems, but more than that, really far more than that, is you've gone through this process of this big amorphous thing called a bill, and now you're down to very specific actions that you're thinking about. Should we take this or do that? Because that's really how the world works. You know, one of the major differences between the scientific method of inquiry and the way policy works is scientists test hypotheses and build knowledge, and they start to understand things. They actually solve problems. In the policy world, we don't get to solve problems. We make things less bad. The policy world is what's called remedial, serial, and incremental. 2 steps forward, 1 step back when you're doing well. And of course, the example I always give is homicides in New York, of which there were 2,200 in 1992, and now I think there were 380 last year. And that's a lot better. The problem's less bad unless you're one of the 380 dead people or their families, in which case the problem wasn't solved. We are not going to solve the problem of pollution, but we have to figure out ways of making that problem less bad if we're going to survive on the planet, and that's what we're trying to do through the workshop. So I think you've had a very successful learning experience based on what I just saw. I think the faculty would agree with me that these were impressive. You've learned a lot, you've distilled a lot of information, and you were able to explain it to us in clear and compelling terms. So you've now just about finished the first third of the program. You're going to have a few weeks off at the end of the week and then come back, and you'll see just how exciting SEPA can be with another 1,000 people in the building. So if you were getting used to riding the elevators whenever you wanted to, that's about to change. But anyway, congratulations, and I wish you all a great break.